Hey everybody,
Hey,
what's up? Is everybody as tired as me? Probably some more and some less. That's my guess. I'm gonna.
I'm probably more.
Um, yeah. I don't know what the metric is though, right? What's the metric?
The metric.
The metric. How do we measure it? How do we?
Hmm.
For example, you could do the what time did you go to bed last night? What time did you get up?
Okay. For me, that would be 5:30, and I woke up at 10:30,
Oh, hang on, is that me?
so I'm still quite raw.
You went to bed at 5:30 and got up at 10:30.
Hmm. So that's proper five.
Yeah, where am I at? I went to bed at about a little after midnight and got up at 5.
Oh,
That's
dang.
that's that's pretty
That is a bit
comparable.
less.
That's comparable though. Yeah, man, but today is the last day for me. It's the last day of the semester. Last lecture day,
Last.
whatever.
Yeah.
Last class day. And last class day of the school year.
Oh, yeah.
Oh, yeah. I don't know if I'm ever going to adjust. I just like, I'm always so fried by the end of a semester.
Hmm.
I don't know. I don't know if I told you guys about when I was at Oregon State, it was a quarter system. So
Whoa.
no semesters. So everything went 10 weeks. And I'm telling you, that is sweet. If you really need to do big projects like you would get in a semester, they just stretch them
Hmm.
out over 2 semesters, right? Have to take both classes. But 10 weeks, man, the body is built for 10 weeks. I don't know that the body is built for 16 weeks, honestly.
Yeah.
So then when I got to on faculty at BYU and I was back to, the semester system, I just remember the first semester I was there, it was like there was one week it's just like I was just slogging, I was like walking through molasses or something. And then I
Hmm.
realized that it was week 11 and
Oh,
my body was just kind of like, hey, we're done, right? We're done, right? We get our break now, right? And I'm like,
school's like,
a month and a half
nope.
more to go. So I don't know if I ever really, that was 20 years ago. I don't know if I ever really recovered.
Yeah. No, it's crazy how like our bodies are tuned to just stay on schedules. And sometimes we make schedules without even realizing it. And when we break it, wow, things get messed up.
Yeah, yeah, exactly. And some of them are like, kind of quick turnaround kinds of, little biorhythms, lunchtime
Yeah.
or whatever, and sleep
Yes.
cycles. And some of them are these larger rhythms, like a semester or a school year or whatever.
Hmm.
But we made it. We're here. We almost made it.
Almost there.
We were almost there, yeah.
Large projects due at midnight tonight.
Yes, but no. Yes, but no.
It's like available till the 30th, you said?
Yeah, yeah, you can turn it in. It's due. It's due tonight. It is turn inable by the 30th.
Hmm.
So you have another week. In other words, I mean, I would recommend everybody like try to pound it, and be done.
Yeah.
But if you don't, it
And
is
that's with no consequences
no
till the
penalty,
30th,
no
right?
penalty at all. That's right.
Okay.
The
It's just
the
like you get it done now, you're done.
exactly, get the whole dang thing done and be done, and focus on whatever
Hmm.
other finals and stuff you got. So that is the official. I think I've posted to everybody on. Yeah, I did last night. I was
Yeah,
posting
last
that.
night.
Hmm.
Hmm.
That the large project is officially due tomorrow, but I'll take it until April 30th with no penalty. And same thing for like homeworks and module exams. Ordinarily, all the turn-inable stuff would have to be done by tonight. That's all homeworks and, but, and the large project. But given just the full disruption of everything, and I
Yeah.
think this class was kind of hard hit. I think I shared the data last time, didn't I? The fear data.
Yeah. They're still
So
lots of tests.
yeah, it's a little bit scary how much not done there is. So it is. I'm just kind of opening that up a little more. Um, okay, my friends. Is there any other housekeeping stuff that we need to deal with? Oh yeah. There were two actually. One was we talked about. So we did a help section
Hmm.
on the large project. Whenever it was, a couple days ago. I don't remember what day it was.
Actually, was that yesterday? It was either yesterday or the day before.
I bet it was. I bet it was Tuesday. It was Tuesday. And I just want to say one thing about that. We can come back to this, but about the large project, we were toying around with this notion. The big problem with the large project, one of them I've spoken to it, is the thing gets big enough, right? And then
Hmm.
all of a sudden you're like, my branch instructions don't work because it's PC offset 9 and I'm trying to bop around, you know, and I
Yeah.
can't reach it. So I was playing around during the help section for those that were there live. And I swear to you, I thought, sincerely as I can be, um, I thought that you could go dot fill and a label. Unless somebody's actually got some product that it works like that, um, on the LC3 simulator that we use, it doesn't work. And now my issue with it, of course, is that the symbol table has all those symbols,
Hmm.
right? It's got all the labels, right?
Hmm.
Vlad, were you going to say something too?
Oh
I
no,
just I just saw your little icon light up.
oh
But
my bad.
no, not a problem at all, man. I like to feel less lonely, so I appreciate it. Um, anyway, so it turns out with the LC3 simulator that we're using, which is kind of our standard, for the class, and I'm okay with that, and it works great. I think it's really a great little product.
Hmm.
But no can do. You cannot just go, you know, you can't make a little jump table, a little state table, with the addresses of all the state, you know, of all the states, the routines that run the states, and then just load it by saying dot fill and then the label like the like state A, state B, whatever. I was a little bit stunned. Those who were there live know I was a little floored because I just really thought that would do the trick. And I also went looking for, some solutions by the author that are kind of provided as part of the publishing stuff, relating to that problem. And all the solution stuff that he did, BR's branch. There weren't, So I was like, "Ooh, okay. So I did two thoughts. Okay, I'm gonna just kind of hit these first, and we're gonna talk about stack, and we're gonna finish. The stack will go fast, and that's the last lecture. But there's a couple of approaches. One is you just keep using the branch, but you recognize as you architect this thing, as you lay it out, you recognize that you have a limited, capacity to bop around, and that you can't just jump from anywhere in your program, from one end of your program to the other. You'll be outside of range. Okay, so you do have to just think about that. Okay, just kind of keep that in mind as a problem you'll have to solve. So you're not just shocked, because when you first take off, you're going and you're like, hey, this isn't too bad. And then one day you're like, oh crap, the branches don't work. I'm throwing assembler errors. So one approach is just to recognize what the distances are. One approach is things like you can dedicate a register to certain values, you know. So when you're way the heck at the bottom, if you want to like go back to the start, you could just store that value in a register, for example, right?
Sorry.
Or what else could you do? I just had an idea. Oh man, I think I maybe did a really hard. So the other approach, that's one approach. Be aware of where stuff's going. The other approach, because I was trying to noodle over this idea of doing like multiple .org, so I could like put each routine in a different spot. Then I would know what the addresses are. Then I could hard code those addresses, you know. But the thought I just had was about it was dumb. It was dumb. It wasn't real.
Yeah, it doesn't let you do multiple .orgs.
Yeah, you can't. Yeah, you can't do that part, and you can't do multiple. You can do a .org, do your routine, you know, assemble it and load it, and then do that again with the next routine. So you can go. There's something like at least 40 different routines to do this state machine. So you could do that 40 times, and then like it'll load them in separate spots in memory, but I can't. But I can't test it. That's the problem. I won't be able to test it, you know, because I'm not going to load 40 different, you know, things one at a time. So that doesn't work. But here's what I did. I wanted to do a solution that didn't involve branching all over the world, you know, that would basically use a structure which is in a common structure in assembly language called a jump table. We've toyed around with that a little bit, but the idea is I allocated memory way at the very top, okay? At the very beginning of the program, I allocated memory like 50 spots. And the idea is I want to put all the addresses, you know, for all the routines into that spot, and then take a register that always just holds on to, you know, the starting address of that table. Okay. So how do you move around? This is the trick. You assign every state to a value, a number. So maybe the start state is state 0, and then, you know, the A state is state 1, and the AD state is state 2, and the AN state is state 3. In any case, you give a number to everyone. And then the idea is that when you put the addresses of all of those routines into that table, you index into the table via the state number. So if I'm on state 23, I take the base register, I add 23. Okay? I add 23, which is the value of the state, and then I get an offset into the spot. Now I'm at the location of the state routine for that particular state. I don't know if that's making sense or not. If it's not making sense, you may want to just stick with managing the branches. But if you want to be a little more courageous, this is another way. Now, here's the only problem. There really isn't any way, and I think this is true, as near as I can tell. There's no way in the LC3 to stick an address into a location in memory other than an LEA or a hard code. I can hard code an address into memory with a dot fill by just giving it a number. But if I want to use a label, I have to do LEA, and that's PC offset 9. So I'm limited. See what I mean? Are you tracking with me here? By the way, sometimes the mic cuts out. So if you're talking and I'm not hearing it, then then hit me on the Discord chat, okay, which is up, and let me know like you can't hear us, and I just gotta kill the call and relaunch it. Oh, you know what else? By the way, I just realized something too. Dang it! No, we got this. I was not streaming the video into Discord, which I'm going to do right now. So, can you guys hear me? First of all, before I do that, can somebody unmute and let me know? You can hear me. Oh wait, I can't. Wait. Okay. Oh wait. Can I hear you? I guess no. Here, let me try something. Okay.
Justin.
All right, you're back. It works. No, this is really an annoyance. Okay, but it's okay for me because I'm just gonna do the go live now. I didn't have the stream rolling on Discord. There we go. Okay, there we go. That's better. Sorry for Discord pals. You can get off YouTube now and go real time here. Okay. So anyway, the problem is that the only way to get an address like of a label into a register is LEA, and LEA is still stuck with PC offset 9. So there's no like global way to load addresses that I can tell.
Oh, I see what you're saying. So like you'd put a label on that table, but you're saying even if you were to get that table's address, you'd still have to use the PC offset?
For the
That
individual
we don't have.
routines, like let's say I have routines called state A, state B, state AD, state AN, state AND, etc., right? And all of those are routines that have a label, state, whatever. And I want to just get the address of state A into that jump table, the address of state B into the jump table, right?
Yeah.
So how do I do that? And I really thought at first I could just go, here's the location in the jump table, and number 0 is going to just be, whatever, dot fill, and then the label of that routine name. It's in the symbol table,
Yeah.
and no dice. And I don't even know if that's conceptually unacceptable, but it doesn't work in the simulator. Because then you're just using the jump table, as I said. And then all you do with the jump table, you're like, what state are you in? You want to go to state 14? Okay, I'll take the register that has the address of the jump table, and I'll just add 14 to it, and then I'm just going to jump to that. I'm going to basically, I'm just jumping through the table. So basically, that's going to index my way in. I'm going to load. What I'm going to do is then I'm going to go there, load that register, then jump through that register. It's almost like a jump indirect, ish. Anyway, so how do you do that? So here's what I did. And it's kind of clever. I essentially built into my program like a little crawler that would crawl my code and shove all the addresses that I needed into the jump table. So here's what I would do. Here's my little routine to do like state A. Then right after it, or it could be before it, but depends on how you wanted to do readability. Right after it is this little, I called it like pre-state A or pre-A. So I would start at the very top running my little pre-routines, and it would just branch, so it's using the local branch to this pre-A, and pre-A, since it's super close by, would grab the address of A, right? And then just put the address of A, load it up, and then throw that in the state table, in the jump table, indexed by the current state, which I would then increment and jump to the next one. And so this increment value is moving my way through the state table, and it's just plug and chug. And then when I get all the way to the bottom, what's cool is the state table now exists. So to start the program, after I get all the way to the bottom, I just do the jump through state 0 to go to the top where the program starts. So it's kind of cool. It adds a little, clutter. But anyway, I don't know. I'm just throwing that out. Just we had a discussion about it, and I wanted to make sure that we were, I was closing the loop a little bit on what I discovered. And if I were to rebuild that assembler myself, I would be pretty emphatic about allowing dot fills to use labels. That just because, look, it's in the symbol table already. There's a label and there's a value. And the value is the address. I think you ought to just be able to load addresses from anywhere in memory that way. You already have the info. It's arbitrary that you're not allowed to do that. There's nothing special that you would have to do to make that work. Anyway, so other things we did need to talk about real quick, though, on that front. One is help section. We did the help section. We can do another one whenever. Not tonight. Let's not do it tonight. But, anytime this weekend we could do it. So, and there's really two different kinds of help sessions that we were talking about maybe. One is just kind of a large program help session, and which would be kind of a continuation of the one we did. Just, you've got questions. Hey, what about that? Maybe they're repeats or not. I can record it, broadcast it to YouTube, whatever. The other one is just sort of more like a help section on the LC3, on that environment, on the simulator. Little tricks. Just here we go. Let's look through each part, talk about it, kind of make that resource available. So that's another possibility. I'm going to be driven by student need. If you guys were like, no, we got this, then man, I'm good. I got plenty of good things to do. I got to catch up on Tiger King? I don't even know. But I have some catching up to do on a number of things. So, but these are available if you want to do that. Let me know, okay? Just ping me, you know what I mean? Just ping me on the chat, or we can talk about it here if you guys have, some motivation on that. But all right, cool. Okay. Let me see. Are we ready for stack action? We're ready for chapter 10.
Let's rock and roll.
Let's do it. Okay. Let's stack it, baby. I swear this is not going to take that long. I shouldn't make predictions like that. What is going on? Hang on. I'm just trying to open my PowerPoint. It must have upgraded something. Okay, my friends. Here we go. Ready. This only has 20 slides, but a bunch of it is animation. Okay. So Stacks is Curtis. It's chapter 10, module 12. And I promise that I'm going to fix the numbering. This summer, I'm going to fix the numbering. I swear it. Okay. Ready?
Let's do it.
The stack. Now, why is it saying the stack and not stacks? The reason is because there is this data structure called a stack, and it is a kind of a counterpart to queues, which we'll talk about. You get into queues, I think in like 2420 maybe? Somewhere in there, I think you start to talk about queues. Maybe quicko intro in like 1400, 1410. But there's also in classic sort of machine architecture, the stack. A lot of systems have a system-wide stack, okay, that does certain things. This is going to be pretty high level, okay? We're not going to get deep into the grunge. You've suffered enough with some deep grunge that was necessary and no way around it. But this is more like a gentle introduction to the stack, you know, both as a data structure and from kind of an operating systems perspective and a low-level architectural perspective, okay? Right on? So the stack structure as a data structure, it is last in, first out, they will sometimes call it. And it's called a stack because by last in, first out, if this is the base, you put on top, on top, on top, on top, on top. That's called pushing. And when you take things out, you have to take it off the top. I pop, I pop, I pop, I pop, back to the bottom, okay? Not a hard concept. Overflow and underflow, remember that two's complement crapola? Nothing like that here. Overflow, I've got only so much space. The stack is that's right, Brendan, this is stacks as in stacks versus queues. The stack has only so much memory allocated to it, right? Somebody did like a block W and said, you know, like stack dot block W, and then you say how many words, that's how much room the stack has, okay? In fact, you know what would be cool? It'd be cool, I don't know, we don't have room for it, but it would be cool to have you like write a little stack management thing in assembly. That would be fantastic. But overflow just means like if you gave me 100 words for my stack, I'm at 100 words and you try to push. I don't have any more room. That's it. That's overflow. Underflow, the stack is empty. You know, the pointer is like right here. And then you try to pop underflow. Super simple. Unlike two's complement. So here's some stacks. Problem with these stacks as a metaphor is I would probably eat these first of all, I wouldn't eat that many pancakes in one shot, but I would typically like cut a little pie slice, you know what I mean? And go, when I get my little couple of buttermilk pancakes at IHOP, I'm usually leave the stack and kind of cut it down like a pie slice. So it doesn't really work, doesn't hold up. The mail gets stacked, but you don't have to pull it off the same way. Same with dishes, you know what I mean? You might think you put them in like that, but the reality is you pull them out of the dishwasher and you put like 4 in at a time. So the metaphor breaks down. So they'll talk about it's just like plates or, you know, or pancakes or whatever. And it's not just like plates or pancakes because you can always, you know what I mean? You can move too many and you can compromise the integrity, okay? This is what it's actually like, all right? This, anybody familiar with Migros? I think it's, it might be a grocery store in Switzerland maybe, but it was the best stack picture I could find of, you know, grocery, what do we call these, shopping carts, okay? This is a stack. You know how I can tell? Rigid structure on the side, rigid structure at the end. It's all concrete, right? And when you need to take a cart out of this thing, where are you taking it from? Now, this is actually 3 stacks, right? Where are you taking it from? You're going to take it, you know, you're going to take that one just right there, you know? And if someone's going to come return, they're going to push it onto the stack. So the base of the stack is at the end, and the top of the stack is near us, okay? Like a Pringles can, however, hang on. I just happened to have finished some Pringles yesterday. This can. No, I did not eat all these in one setting. But so, yeah, they sit there stacked like a Pringles can. But the problem is when I get Pringles, or ironically, I actually prefer the Lay's, and they're called stacks. To me, that's actually a better fabricated, artificially shaped potato chip. Okay. So the problem with the Pringles can, Josh, is when I go to serve myself, I usually tip it and I'll grab like an inch of it. You know what I mean? I'll grab a bunch from the end, at which point I'll tend to take them off the top. But you see, the metaphor breaks down, right? That's all. But over here, really, Walter? Not even real Pringles. Walmart brand imitation Pringles. Man, I don't know, man. There's no accounting for personal taste, sir. I don't know what to say. Okay, yeah, so Brendan talked about cues. I am going to talk about cues, but I appreciate that pointer as well. But you see how that's a stack, okay? That's a stack right here, a stack of grocery carts. You have to pull it off the top, and if you're returning one, you have to return it to the top. When I pull one of these out, that's a pop. When I return one back, that's a push, okay? Now, I want to go, do I have, nope. Oh, I thought I had. You know, I'm just a constant series of disappointments to myself. I had somewhere another picture. It was the cue picture for Brendan. So I want to just say this. Let's talk about the stack of grocery carts for a second. You know my big problem with the stack of grocery carts? Number one problem is these grocery carts out here on the end, they're getting, about 10 or 20 deep. Those are getting just used like crazy. And then way at the bottom, you're not going to get to that one until Black Thursday, or, you know what I mean? Saturday night before Mother's Day, or, whatever. I don't know when people are doing the big grocery shop. Christmas Eve, night before. You know what I'm saying? And so you get these busted to crap grocery carts on the back end that have the one wheel that goes, right? I don't know why. Why is it? It's like a natural law. Every grocery cart in the world apparently has to have one wheel. It's a front one. Usually it's the right. I don't know why. And it's going, brrr, it's just hard life. You know what I mean? Just hard living, being a grocery cart. But the stack exacerbates it. Now, in contrast, you have these also at Walmart, where you can buy the imitation Pringles, Walmart brand. But also at Walmart, there is a queue, okay? In fact, dang it, you guys, I'm just not going to live with this, okay? Hang on. I am going to generate the picture I'm looking for in real time. I could never do this in the classroom. Maybe. Or maybe I'm just blowing smoke. Just wait, hang on. Oh yeah, here we go. Well, this one, nah. Somebody already score one for me here. I haven't been checking the Discord chats. No. Okay, those are off. Oh, here's a good one. The headline is "Grown Woman Gets Trapped in Grocery Cart." So that's fantastic. I don't know how you pull that off. You got to be working at it to get that done. It takes a certain commitment. Okay, well, I may have to work. I may have to work at this again. Okay, well, I can probably show you. What I'm looking for is the one where they're coming in one side and going out the other side. Come on, if somebody can race me on this and find, I mean, I have one, but just the resolution is bad, and I'm too persnickety. Oh man. Somebody got something? Can I not hear you guys anymore? Nah, I'm not finding the sweet spot. Also, Costco does it. Can I hear you? Are you guys talking and I'm not hearing you? I can't hear you. Well, stink. Okay. No, this is me just like being stubborn now. Yeah, it just shouldn't be that hard, you know what I mean? And the problem is actually that most of what I find when I go hunting for these is in fact stacks, not cues. Yeah. Alrighty. Okay, well, to heck with that then. There actually was like one picture which just because I have to not go down into complete flaming defeat, I'm just going to show you that one. I'll drag it over. Okay, hang on. We got a contribution. Yeah, there we go. Everybody can see that, right? Okay, no, that's fantastic, man. Can can everybody see that? That's what Brendan contributed. Here we go. There we go. Yeah, right. So, thanks, Brendan. Sorry for the delay on that, you guys. It's like just lack of preparation or something, man. Okay, so yeah, so you see the idea. This is what is called a Q. It's a Q, which is spelled Queue. Okay, and I don't even know if I have a slide with that word on it. But Queue. This is what the British actually refer to. We say a line, get in line, and they say queue up or get in the queue. So they apparently like to name their societal structures after data structures. We have stacks, queues, and then in our personal lives we have lines. But yeah, you can see in this picture that Brendan provided that you're returning your carts, right, coming in this way, and then you're taking them going out the other way. Okay, that was a lot of overhead for very little gain. Let me get rid of that guy. And by the way, are we dead on the me being able to hear you guys? I think we are, right? Yeah. Shoot. Okay, hang on. I'm going to do the disconnect. Okay, I'm back. I should be able to hear you guys again.
Can you hear me?
Yeah, I can now.
There you go.
How frustrating. It's really, really frustrating.
Do you want to know something funny?
Yeah.
Even though queue is like a British word, their shopping carts don't work like a queue. They work more like a stack because you have to like insert a coin to take out the last cart.
At a grocery store?
Yeah, at a grocery store.
You have to pay to use a grocery cart at a
Well, you get
shopping
the
cart?
coin back. So like most of the time they'll like the store will
Okay.
have little coins you can borrow if you ask to
Yeah.
register. Yeah.
Okay.
But it works like a stack, not a queue out there.
That's funny. But no, you know, and you know what I realized too is that when you go to the airport and you are like at the bag claim or wherever, and they've got, you know, carts you can rent, again, you put the quarter in or whatever and you get something back.
Mm-hmm.
Those tend to be queues. All right. So, and I don't even have a great graphic, but I want to just show you the comparison. And my artwork here is going to be tremendous. You see this right there? That's beautiful. Okay, the idea here is that with a stack, okay, this is the whole idea right here. Okay, that's the difference right there. In other words, in this space, there's like storage space. Okay, let me, if I kind of draw that in there. There's storage space. It's like locations in memory. Okay, like an array, for example, or a string or whatever. Right? These are like locations in memory. The queue stuff comes in the one way. I can't. Which way am I here? Stuff comes in this way, and then goes out that way. Okay, sometimes called first in, first out. Sometimes they'll call it a FIFO. Which is slightly goofy, but right, the first one goes in is the first one that's popping out. Other way, sorry. The stack is called LIFO. Last in is the first out. So you push it on top, and then when it's time to pop, that's the one that goes away. Everybody good? That's not crazy, right? This is in nature all the time. This is all around us. Okay. Let me see. Oh, nice, Brendan. Trolley shoppers queue for shopping at Costco. This was where? This was in the UK. Queuing. And are those people like hoarding water in that one picture, Brendan? I don't know. I can't see. It's too... It doesn't blow up big enough. I don't know either. Okay. All right, back here. Anyway, stack. The stack is important in the context of system software, system structures, and some machines have a built-in stack for the overall operation of the computer. You can also make your own stacks, but there are often these system stacks, okay? Okay, so here's an example of how it works again. This is like this is so easy, okay? Right? I got a stack, I push 2 on it, I push 3, I push 4, I push 5, I push 6. These are just values, they could be anything. And then I'm popping. 6 comes off, 5 comes off, 4 comes off. This would be a better example if they weren't in order, because then all of a sudden you're like, what does the order mean? Because you're like, it's overfitting the data. You see a pattern that isn't really the point, but there is this like goofy pattern. Here's another one, and these are just to get you familiar with different representations of it. This one, I do this push, and I've got a stack pointer, okay? I push a 2, it's on the stack. Now, there's 2 ways of conceptualizing the stack pointer. You can have it point to the top element, or you can point above the top element. Doesn't matter which one you do, as long as you know what you're doing. You know, I think the convention is to have the stack pointer pointing to the top element. Then when you go to push, you have to increment the stack pointer then put, the value there, and then you're stationary. The alternative would be that you'd have it pointing above, so it's just a matter of what order you're going to do the thing in. If it was pointing above the object, or the last, thing, then I would put it where the stack pointer points and then increment the stack pointer. Either way works. There's no logical difference, just a question of how you want to do it. So this is one where I'm pushing, popping, then pushing, then popping, then popping, and then popping, okay? And this is nice just because it shows a little bit more mixing it up with, I'm pushing stuff on top, and then when I pop, the one goes away, which gets me back to looking just like I did over here. Now I push 21, etc. Okay. The other thing we'll kind of get to is this is just pushing and popping. When you try to do like you can do math operations on a stack. Like if you have a stack-based system, you can do like an add, which will take, since that's a binary operator, it wants 2 operands. It'll basically grab the top element, pop it off, grab the next element, pop it off, add them together, push the results back on. So same thing with like a not, whatever the operations are, that's the basic idea. Here's another one. This is borrowing, this must be an example from the book. So this is now trying to drag you a little more into the world of LC3. Okay. And so in the world of LC3, oh dear. Oh, I'm too tired. In the world of LC3, what we're going to do is show you this one. Yeah, there's just one more slide on this one. So this is just to kind of say, here's our stack, okay? And these are locations in memory. You might note that these look like locations in memory in the LC3, right? Which is what they are. And then this is the stack pointer, okay? You ready? So this stack pointer, which points to the top, is currently set, in essence, beyond the stack. Now you can also think of this, how we set up memory with like 0, 0, 0, zeros at the top and FFFFs at the bottom. This is following the same idea, where the addresses are going that way, okay? From top to bottom, they get smaller to larger. But the stack is growing this way. Now you got to understand too, there's no like standard convention on how to represent this. You can look at memory as starting at 0 at the top and going down to FFFF. That's entirely reasonable, and maybe even, oh dear, maybe even common. But you can flip that and have the zeros down here and the FFFF up here too, right? I've seen it both ways. Independent of which way you set it up, you've got a stack that's a certain amount of space, and you could have the stack with the bottom here growing this way, or the bottom here growing this way. So you're going to have 2 variables at play. Which way you're going to have memory going in your representation, and which way you're going to have the stack growing in your representation. Okay? Aren't those great visuals? I feel like I should be, I don't know, the airline folks, when they're like trying to tell you where the exits are, like it's going to, I don't know. Okay? So in this case, so just understand this is not like the way stacks work. This is one of 4 different ways of orienting it, okay? And it's okay. Memory goes from 0, 0 at the top. Sorry, man, sleep deprived. FF at the bottom, okay? Then we've got a stack pointer that's at the bottom of the stack, and the stack's going to grow this way. However you need to get your head around that, that's what you have to do, okay? So in this case, the stack pointer is 4,000. hex, which means the stack pointer is at the current element, but it's below the bottom of the stack. So that's an empty stack. Then there is a push. The value 18 gets dropped in, and the stack pointer gets moved. The top of the stack is bumped. Now it points at that guy, which means that value is 3FFF. I'm into the yawns. Can you tell? I am underslept this week.
And the day has just begun.
Yeah, speak for yourself. I had to get up at 5 to get some stuff done. So my day is almost over, apparently, from the sounds of it. Anyway, we push 18 and we move the stack pointer. Push 31, move it. Push 5, move it. Push 12. Well, sorry. When we were sitting here at the last item, then we go increment, put it, increment, put it, increment, put it. That's the way this orientation works. Oh yeah, that's right. Actually, there's 8 different combos. Which way you count memory, which way the stack bottom or top is, right? Which way that is, and then whether you have the stack pointer pointing at the top element or above it. That's 3 different variables, which means 8 different ways to monkey with it. 2 to the third. Okay, so the stack pointer is pointing at that guy right now, which means the stack pointer is 3FFC, which is just an address. Stack pointer is just an address. Okay, you could also do a stack pointer with an index, which gets added to, there'd be like an address for the stack itself, and then an index that was, showing where the stack pointer was. That's another possibility. And then depending upon where the stack's moving, that index might have to be shrinking or growing, subtracting or adding, depending upon which way it has to go for the conceptual integrity. Anyway, I'm so sorry. I'm probably causing you to yawn, right? Am I triggering any yawning fits? I suspect I am.
Yeah.
So sorry. Anyway, then we pop, and then this is kind of key. Those values are still there in memory. The fact that you popped, and it turns out that certain security attacks actually take advantage of that idea that there's still memory when you pop stuff off a stack. The other thing to keep in mind that's kind of cool, because we're not going to get really into it here, but when you have what we think of as like a traditional call stack, right? There's just like a method or a function, and it calls another function, and that one calls a function, and that one calls a function. The common way is that when you call this thing, you got local variables and stuff, right? Little context and things. You push that on the stack. Then when that one calls someone else, you push that on the stack, etc. Then, as that guy finishes, he pops off, returns control back to the previous one. When he finishes, pops off, returns control. And so the call stack is a structure where languages use this call stack. Depends on the language in terms of how they use it. Okay. All right. Anyway, there's some classic hacker techniques that rely on the idea that you put secure data in a local function, and then when the function went away, it's still on the stack. So then if the new thing can show up, the malicious piece of software, and be sort of like, have like a statically declared variable with a bunch of space, it'll allocate that on the stack, and it'll encompass all the, stuff that had been done previously by the previous call. Maybe a stored password before it encrypted it, things like that. That's the idea. All right. Here's what this looks like when it's done in like an LC3 type assembly language. If we had this. What's the protocol for when you have to yawn? I know you're not supposed to touch your face. I'm quarantined in my house. I have an idea. Are you ready? Oh. Okay, I'm better. That's what I'll do from now on to spare you. Am I dead on hearing you guys again? Or can I still hear you?
Can you hear me?
Yeah, we're good. Okay.
There
Sorry,
you
man.
go.
This has been the only real technical glitch on using Discord. This part where the call just gets weirdly distorted, and I
Which
can't.
is very weird because
I
it
know.
just happens with you. Like we can hear each other all the time, but
Really, really. I wonder if it's because I'm the one with the live. I wonder if it's because of the live, the go live.
yeah,
I'm
I
not
don't
sure.
know.
Not sure. I'll keep monkeying. Anyway, this is what it would look like. Okay, that's our push routine. Yeah. So this is going to basically take R6, decrement it 1, just decrement R6. And then what's it doing? Oh, R6 is an address. R6 is an address of the, yeah, there it is right there, R6. It's the stack pointer. And so then I store, what am I doing? Yeah, I store the value in R0, which is what I'm using, to push the value that I'm pushing on the stack into the location pointed to by R6. There we go. Pop works analogously. Okay? Cool? Ready for some math? Let's do some math. Is that helping at all? I feel just guilty. I'm really into the yawning fit because if it's a live classroom, I'm walking around. You know what I mean? I need some strong beverage or something. Okay. What I was talking about was when we're doing a math problem like this, right? A plus B, the quantity A plus B times the quantity C plus D. So I got to get A plus B together, and I got to get C plus D together. The way these operations work, these binary operations, is I need to, as you can see here, I need to take A, load it into R1, take B, load it into R0, load B into R1. What am I doing? Oh, yeah, this is what we already know how to do, right? I would put those in registers. I would add them together, and I would save them. Then I would put C and D into 2 registers, add them together, save it. Then take those 2 registers, right, and add those together. And then in this example, we are creating an imaginary mul. Now that I have the kernel helping me, I'm finding that when the kernel blocks my way, that I can get a good heartfelt yawn going, which keeps me alive for like another 90 seconds. In this example, there's a mul. There's a mythical multiply, because most real assembly languages have a multiply. Okay, and then these are just my values. These are just dot fill. These are the values I'm doing. Okay, and E is where I'm going to put my answer. Okay, that's what we know how to do. So this is what we would do with an imaginary stack-based language like Forth. Forth is not imaginary. But if we had an imaginary language like Forth, here's what we might do. We would, now backing up here, okay, we had A was 25, B was 17, right? So we're going to push 25, push 17, and then do an add operation. So we're going to walk through this thing, okay? We push 25, and we push 17. When we do the add, what happens is the 25 and the 17 both come off, they get added together, and the result gets pushed back on, okay? Then we push a 3, and we push a 2. We're going to add those. So the 2 and 3 are going to fly off, add together to a 5, and push back on. Oh, I forgot the kernel on that one. Then we're going to do the multiply next, which pops the two values off, multiplies them, shoves it back on. That ought to be 210. And then it's going to pop E, which basically says take whatever's on top and pop it and put it into E. Boom. Cool? And watch this. I told you. I told you. So this really is just a gentle intro to stacks. And maybe I need to beef this up a little more. I don't know. I got to check some of the students that have come through this and then gone on to the other classes where they've got to deal with that. I think, what's the one where you get more of the data structures? 2420? Is 2420 the one where you talk a lot more about data structures?
I personally do not know.
Yeah, you guys, what do you know? But you haven't been to 2420.
Exactly.
Some of you might have touched it somewhere somehow, but okay. Anyway, that's it, my friends. That's stack factor right there. And we did our improv on cues. I think what I've probably done in the past is whiteboarded. I think I jumped on the whiteboard is what always happened, which this is now. This is my whiteboard. All right, at this point, we have covered all of the meat of this class. Whew. With like 15 minutes to spare when it was all done. And I did tell you, I mean, I told you that it was going to speed up down the stretch. I did. And, which it did. But also, as it's speeding up down the stretch, it's more like, I mean, if you took the last 3 modules and just kind of lumped the actual material together, I don't know that it is even going to be, you know, the amount of like module 2. You know what I mean? In other words, there's some modules where we are pounding it, you know, with a lot, you know, where you take 2 weeks. This took us less than a half an hour. And honestly, I could spend 2 weeks talking about stacks, but you know, the way I'm treating this here, it was pretty quick. So yes, it speeds up, but it's not like all of a sudden you're doing, you know, this module is not the same as module of any of the other modules. It's much smaller. Okay, so here's the deal. Let me get rid of that. All right. So, oh man. Let's see. Reminders again. I said it at the beginning, but reminder that there's a lot of behindness on the module exams, that I'll take everything until April 30th. The large project, the homeworks, you know, taking module exams, I'll take everything, okay, through May 30th. I got to be done by May 30th because I only have 5 days to do all of my grading for all of my classes and get grades submitted. So if you're having some kind of struggle, you know, that's a little bit exceptional and you can't get it finished, come grab me, okay? Come grab me and talk to me. If I haven't, well, you guys aren't the issue. I know all of you that are live right now, so this isn't even really true. But if there's somebody like, I haven't seen this person since, you know, since they finished module 3 in January, then no, I'm not going to make a special deal. You know what I mean? But if you got like, you know, but if you got derailed with the pandemic, the quarantine, the stay at home, and all the, you know what I mean? There's a lot of disruption. And if that's, you know, if you've been doing your best and then impacted by that, then I've got other options. Tanner, what does not, I was reading it as like, what does not do on a stack? I'm like, your grammar needs work. So Yeah, so Abby is correct. The not operation it pops the top element, performs a not, and then pushes the answer back on because it's a unary operator. That's it. You could conceptually have like ternary operators that would pop three things off the stack, do something, and push a value back. Stuff like that. You could have values that would take a value off the stack, do something to it, and push two answers back on the stack, right? Like take a word off the stack and then like push separate, separate bytes with, whatever. Um, so Zach, oh man. Well, even Abby sounds. If you read it wrong, we're all so dang tired. Like Abby. So Tanner goes, "What does not do on a stack?" Abby's like, "Takes the top element and knots it." We sound so dumb, but only if you ignore the caps and read like an idiot, that's where
You
I'm
gotta
at.
stop, dude. I'm dying.
Oh, and the worst part is it's not that funny. I know it's not that funny, but I'm finding as the semester has been winding down and I've been getting more and more tired that I'm like on Facebook and there's somebody posts something like really stupid and I am just like literally, ROTFL. I mean, I'm just not literally, but I am literally lolling, just like convulsing and I'm like, it's not that funny. Chuck, it's not that funny.
Yeah, that's me right now.
That's me. I had the same experience the other night watching The Office. I find The Office is like 40% pain and then 60% payoff. So it's always that cost benefit analysis. You know what I mean? And it's usually amusing. Like you go, that's The Office. I'm watching The Office and I'm like, and I'm starting to like really start laughing. I'm all by myself, lolling, and then I just know that I've got significant personal issues. So anyway, but hey, this is our last go. We got a few minutes. We don't need to do anything, or if you have any like lingering, just any other questions, any dumb questions, good questions, unrelated, questions not related to, not related to the class, related to the major or career or life or yeah, Tanner just asked if I'd be available. Yeah, absolutely. I'm going to be available on Discord to the extent that I can be, through the 30th of April. And in fact, I'm actually just like checking real quick to make sure. Yeah, I've got like some Tuesday afternoon conflict, some Wednesday afternoon conflict next week. And other than that, I will try to just be available. I've got stuff to do, but I'll be available. Okay. Zach asks, is it better idea to prioritize finishing up the project or turning in the last couple module homeworks? Well, you've got till the 30th on all of those, Zach. The project's due is worth like, what is it, 16%? 14%? I think the project's worth 14%. So I don't know. The reality is modules 10, 11, and 12, they're not that bad. You know what I mean? Really. Module 12 is a cakewalk. You can you can review it, do the homework, and take the module exam probably all in about an hour. I would bet. I don't know. It probably means I need to stiffen that up a little bit. Yeah, I can't say, Zach. It depends on how the math works out, But if you can get the large project done, the reality is you can double back and pound the other out real fast. What else? Oh yeah, SRIs. SRIs. You got the email. Do it. It helps. The bigger the number, the better, the more accurate the representation is. The bottom line, you know. I was just looking to see if I could see how many of those I have. Yeah, it's gonna make me sign in. Yes. Okay. Any other questions? Anything else you guys have on any topic? Anything at all? Oh, Tanner, we talked about Stack Overflow and Underflow. It's on the slide, but it's super, super easy. I've allocated a certain amount of space. If you blow past it, that's overflow. If you try to pop off an empty stack, that's underflow. Or if you had like only one item on a stack and then tried to do an add, that would generate underflow because you'd pop the first value and the second one would fail. So, anyway. Alrighty, folks. I'll be on Discord if you need to chat. You know, need to hit whatever. Oh, Alan. Oh my gosh. You have to be right. That has to be right. So, if you're just on YouTube, Alan said, I posted about this a while ago on YouTube. Sorry, I missed that, Alan. But I don't think you saw it. No, I don't think I did. But assume the reason you can't put a label in, you know, with a .fill is because the pseudo ops have to run before the symbol table is generated. Or, put another way, the symbol table is being generated. You'd have to make 2 passes. 1 pass for the symbol table, but the pseudo ops come into play. Yeah, no, you're absolutely right. You could do you could do like a temporary label and a second pass. You could. That's right. No, Alan, that's right on, man. That's brilliant. I think you're dead on. I did not think of that. Oh, by the way, there have been 12 SRIs completed for 2810. But that's only that's less than 30%. So if you guys haven't done the SRI, would you do that? And if you're digging what I'm selling, then go rate my professors as well. That is more just like, you know, external marketing. I don't know what you really want to call that, but you know what I mean? It has no direct professional bearing. It is nice. Again, when N is big, then that value gets representative, right? There's occasionally just goofy stuff that shows up there. Anyway, all right. Anybody else? You got anything else? Oh man, I think, well, we made it to the end of semester. Good luck getting everything wrapped up. I will be available. And Devin and Talmadge are going to be available as well during we'll let you know what the testing lobby hours for those guys will be, but they'll definitely have some testing lobby time. And we'll try to just keep it mostly somebody on duty to be available. So alrighty. That's all I got. You guys got anything else? Alrighty, I'm gonna go truncate YouTube, and I'll be on the